today we want to look at force, which equals mass times acceleration. And as you remember, acceleration is change in velocity over change in time. Now if we pull the change out front, we get force equals a change in mass times velocity over time. I'm going to multiply both sides by delta t, so I get the quantity F delta t. That's going to equal the change in a new quantity mv, which I'm going to call momentum. So momentum P is equal to m times v. And just as a work changed kinetic energy, this quantity F times delta t, we're going to call the impulse. So the impulse takes the place of work, and instead of changing energy, it changes momentum. Notice also that the impulse is a vector quantity. We can look at the units here. We have for the units for momentum, kilograms, and velocity is meters per second. And we leave that as the units for momentum. So we don't give it a new name. We just leave it kilograms, meters per second. So this is the idea of impulse and momentum. Now many times we might have a force that's not constant. So maybe if we look at force as a function of time, it'll probably be something like this. And so it grows and gets weaker. And so when I write my impulse formula, I'm going to use the average force times delta t. What that means is to imagine my force here. I'm using this force and that's my average force, and that's what I use to calculate the impulse. So I'm averaging out so that what's the same is these two areas. The bell curve and the rectangle have the same area. So I'll get the same impulse.